Hello everyone. Welcome to your Algebra 1 midterm review. We're going to go through every single question in this review packet in order to prepare you for your midterm. As we go through, make sure you're copying down everything that we're doing. If you need additional scrap paper, make sure that you attach it to the back of your packet. Okay, let's get started. Number 1. Which property justifies the statement below? X times parentheses y minus 3 is equal to xy minus 3x. Our choices are A, associative property, B, transitive property, C, distributive property, D, commutative property. There's a lot of vocabulary involved here, so let's take a look at our statement. Now, we're looking to find the correct property that lets you manipulate the left side of this equation, x parentheses y minus 3, and lets you turn it into what we have on the right, xy minus 3x. So if we look at the left side again, we're trying to see what happened to the left side that turned it into the right side. Well, if you notice, x is outside of parentheses that hold y minus 3. On the right side, we don't have parentheses. So how do we turn the left side into the right side? Well, the only way to get rid of the parentheses is if we distributed the x to the y, meaning we multiplied x times y, and then we also distributed the x value to the negative 3. We did x times negative 3. When we do that, we get x times y, negative 3 times x. This is known as the distributive property, choice C. Let's go through your other choices just so that you're familiar with what the other choices mean. Now, the associative property means that you can add numbers when they're grouped together in any combination. So, for example, if I had 3 plus a, and this was in parentheses, plus b, it would be the same thing as doing addition in any other order by grouping them together. So 3 plus, and then I'm going to group a and b together. That's an example of the associative property. I can group anything together if all I'm doing is adding the whole way across. B, the transitive property. You're going to usually do this one in geometry, but just to give you a preview, the transitive property would say if A is equal to B and B is equal to C, that since they're both equal to B, A would equal to C. It's a train of equality, but we'll talk about that in geometry next year. The distributive property we just saw an example of, and lastly, the commutative property. The commutative property says that you can add things in any order. So if you had, similar to the first example, 3 plus A plus B, this would be the same thing as saying B plus 3 plus A, or any other order. It says you can move these things around, you can commute them, you can move them around if all you're doing is adding them all together in the end anyway. So those are our different properties, and clearly choice C is our best answer for what we have as our statement. Okay, let's move on to number 2. Number 2, write the translation of 3 times the sum of a number and 4. So our goal here is we're going to translate these words into some algebraic expression. So let's see what we have. 3 times, so we're going to multiply something by 3. 3 times the sum of a number and 4. So what you're doing is you're going to multiply 3 by everything that comes after. So I'm going to start this out by saying 3 times, and I'm going to put this in parentheses. What's going to go here is the conversion of sum of a number and 4. So 3 times this yellow piece. The sum of a number and 4. Well, a couple of vocab words that we have to know here. Sum means addition. So you're going to be adding things together. So the sum of a number and 4. When they say a number and they don't tell you what that number is, you can give it a letter, a variable. So I could use the letter N for number, or a very common one that we see all the time is X. So the sum of a number and 4. So that's the other thing that I'm adding. A number plus 4. So I'm going to put a little plus sign in between them. So going back to what I have on the right here, 3 times the sum of a number and 4. So that's going to be the answer to part A. Let's look at part B. Write the translation of 6 times the difference of a number and y. Okay, so again, we're doing a translation. So we're going to convert these words into an algebraic expression. Now we have 6 times. 6 times. So I'm going to do the same thing I did before. I'm going to get started and I'm going to say 6 times something. Okay? 6 times the difference. Difference means you're going to subtract. So in the middle here, I'm going to subtract. 6 times the difference of a number and y. So a number again. That means we can choose what variable we want to use. The variable that we're not going to use is y, because we've already used y here. So I'm going to choose some other number, or rather some other variable, and I'll choose x. So the difference of a number and y. So here are my 2 variables, a number x and y. And since I'm doing the difference, I'm subtracting. So it's going to be 6 parentheses, a number minus y, the difference of those 2 things, and that's my final answer for B. Number 3, simplify the 2 expressions below. We're simplifying. So when we're simplifying, we want to get rid of things that could be combined, or parentheses, or exponents that could be multiplied. So we want to get it to the simplest form so that it doesn't look so intimidating when we're looking at it. So let's look at the first one. These are 2 different problems. Okay? So we're treating these 2 things differently. Okay, so for the first one, we have 10 minus 4 parentheses 2x plus 7. So whenever I have parentheses, according to PEMDAS, I want to look inside of the parentheses to see is there anything in here that I can combine or simplify before I get started. Looking in there, 2x and 7 are not like terms, so they can't be combined. So I'm going to move past parentheses. There are no exponents, there are no exponents. So let's move on to multiplication. Whenever you see parentheses, that means there's multiplication involved. Now, let's see what these parentheses are being multiplied by. Outside of the parentheses, not just a 4, it's a negative 4. So what we're going to do is we're going to multiply that negative 4 by everything inside the parentheses. Before I get started, I'm going to bring down the 10 because I'm not even going to deal with it right now. I'm going to focus on the parentheses. So 10, and now the negative 4 is going to multiply by 2x. One's negative, one's positive. So we get negative 8x. Next, negative 4 times 7. Again, you're going to get a negative since the signs are different. 4 times 7 is 28. This looks a lot clearer than it was before when we had the parentheses. So let's keep going because we're not done. The next thing that we're going to do is we're going to see if we can combine any like terms. I'm going to start with the x values. All I have is a negative 8x. I don't have any other x to combine it with. So I'm just going to write negative 8x. And now I'm going to take a look at my other numbers. So I have 10 and negative 28. When I'm combining these, when I'm adding these, I'm going to take a look at the signs. If the signs are different, I'm going to take the sign of the larger number. So between 10 and 28, when I'm looking at the absolute value, 28 is the larger number. So I know my answer is going to be negative. And now, once I do that, I take 28 and 10 and I subtract. So 28 minus 10 is going to give me 18. So my answer here is negative 8x minus 18. This can also be rewritten as negative 18 minus 8x. They can switch places. All right, let's go on to the next one. 4 parentheses 5w minus 3 minus w minus 1. 2 sets of parentheses. Now, in our first set of parentheses, 5w minus 3, I can't combine anything. In my second set of parentheses, w minus 1, I can't do it either. There's no like terms. So I'm going to move on. There's no exponents to deal with, so the next thing I'm going to do is I'm going to start multiplying. Let's look at the first set of parentheses, 5w minus 3. Outside of those parentheses is a positive 4. So what I'm going to do to start simplifying is I'm going to start multiplying, distributing the 4 to 5w, and then the 4 to negative 3. 4 times 5w gives me 20w. Next, 4 times negative 3 gives me a negative 12. Let's look at the next set of parentheses. You want to be careful with the next set of parentheses. Outside of w minus 1 is a negative sign. It's like it's a negative 1 in front of the parentheses. There's always an invisible 1 in front of any set of parentheses. So what we're going to do is we're going to distribute that negative 1 to both terms inside of your parentheses. And some people forget to do this. So the negative is going to multiply by w, and then it's going to multiply by negative 1. So distribute it to both terms. Now, if all you're doing is multiplying something by negative 1, that means you're just going to flip the sign. Change whatever sign it is, from positive to negative or negative to positive. So negative times w gives you a negative w. Negative times negative 1 gives you a positive 1, since you're multiplying two signs that are the same. So this looks a lot cleaner now. Let's start combining like terms. So I have 20w and a negative w. Those are my variables. So I'm going to combine them. 20w minus w gives me 19w. Then we have negative 12 plus 1. The signs are different, so you take the sign of the negative 12, so it's going to be a minus, and then you're going to take the difference of 12 and 1. You're going to subtract. 12 minus 1 is 11. So your final answer is going to be 19w minus 11. Just like the last one, if we rewrote this, it would be negative 11 plus 19w. Okay, let's keep going. Now, before we do, just remember, the most important part of these two questions was right here. That sneaky negative in front of the parentheses, you need to remember that you have to distribute it to both terms. You have to multiply the w by a negative and the negative 1 by a negative. So make sure you do it to both terms inside the parentheses. If there's more than just 2 terms, if there's 3 terms, then distribute it to all 3 terms. Make sure everything in the parentheses gets multiplied by that negative. Okay, let's move on. Number 4. Which of the following expressions cannot be simplified? All right, let's look at the first one, A. Well, for A, I can see there are parentheses, 6 times parentheses x minus 4x plus 2. Well, I can always combine x minus 4x, and then I could always distribute whatever I have outside of the parentheses to the inside of the parentheses. So I can definitely do more work here. So it's not fully simplified. So I can simplify this. So it's not choice A. I'm looking for one that I can't simplify, that it's in the simplest form. Let's look at B. 3x minus 7x plus 1. Well, 3x and negative 7x can be combined. So 3x and negative 7x, that would give me negative 4x plus 1. I can definitely combine things there, so it's not simplified. Cross out B. Let's look at choice C. Negative 12x minus 4. Negative 12x has a variable. Negative 4 doesn't. So you can't combine them. That is in simplest form. So right now I'm going to say yes to C, but let's not forget D. Now for D, it's negative and then parentheses x plus 4. When there's something outside of the parentheses, I can always simplify it by multiplying whatever's outside the parentheses. So I can simplify D, and let's review how that would look. Negative times the x, negative times the 4 would give me negative x minus 4. It would change the sign of both of the things, both of the terms inside of the parentheses. So it's not going to be choice D either. I can simplify choice D. So it's choice C. That's the only one that cannot be simplified. It is in simplest form. Okay, let's move on. 5. What is the perimeter of the rectangle below? So our final ask is to find the perimeter of the shape below. Now this shape is a rectangle. Now what you need to know about a rectangle is that opposite sides have the same length. So this side, x plus 2 on the right, is going to be the same as the side on the left. It's also going to be x plus 2. The bottom is 3x minus 7. So the top should also be 3x minus 7. Now the question is, why is that important? Well, perimeter means that you add up all the sides of your shape. I have 4 sides here. So in finding the perimeter, what I need to do is I need to add all 4 sides together. The first side plus the second side plus the third side plus the fourth side. So let's put in all of these blanks, what we have as our 4 side lengths. So I have x plus 2 and x plus 2. I also have 3x minus 7 and 3x minus 7. So all I'm doing is I'm adding together all 4 sides of my rectangle. If this was a triangle, I'd be adding 3 sides. If I had a pentagon, I'd be adding 5 sides together. So perimeter just means that you're adding together all the side lengths so that you find the length the entire way around your shape. Okay, let's go ahead and do the math. So the perimeter is equal to, let's start combining like terms. I have, starting with the x's, an x here and x here, a 3x and a 3x. X plus x gives me 2x. Then another 3x is 5x. And then the last one gives me 8x. So I have 8x. Okay? X and x was 2x. Plus another 3x is 5x. And then another 3 is 8x. And then I have whole numbers. I have 2, 2, negative 7, negative 7. So I'm going to write that out. I have 2 plus 2, then a negative 7 and a negative 7. 2 and 2 together gives me 4. Negative 7 and negative 7 together, since they're both negative, I'm getting even more negative when I subtract 7 from negative 7. So I'm going to get a negative. 7 and 7 is 14. So it's 4 minus 14. So since 14 is the larger number, I'm going to take the negative that's in front of the 14. And then I'm going to subtract. 14 minus 4 is 10. So 8x minus 10 is going to be the perimeter of this rectangle. And that is my final answer. So anytime you see perimeter, that means add up all of the side lengths for your shape. Now, if there's a side length missing, like we saw here, the top was missing and the bottom was missing, look to see if you can figure out what that side length is by looking at the opposite side if it's a rectangle. Okay, let's move on. Number 6, solve the 2 equations below. So again, these are two separate problems, and we're asked to solve them. Looking at the first one, I have x over a -4 plus 7 equals -1. Now, when you're trying to solve the two equations, you're looking to get the x value all by itself. Right now, x is being divided by -4, and then whatever I get from that, I need to add 7 to it. When you're trying to isolate your variable, you're going to be doing PEMDAS in reverse. So I'm going to write PEMDAS up here. And then I'm going to tell you you're doing it in reverse. So what does that mean? You're going backwards. So you're going to start by getting rid of whatever is being added or subtracted first. So you deal with the addition or subtraction first. Then you deal with whatever is being multiplied or divided next. And then you can get rid of an exponent and then deal with what's inside of the parentheses. Okay, so let's start looking at this problem. The x is being divided by -4, and then 7 is being added. Remember, we're going to deal with the addition and subtraction first. So I'm going to start with the +7, and we're going to get rid of that first. The easiest way to get rid of a +7 is do the opposite. You're going to subtract 7 from both sides. What you do to one side, you have to do to the other. 7s are going to cancel. Now, we're left with x over -4 equals, on the right-hand side, -1 minus 7. You're getting even more negative. You're going to get to -8. Now, I want to get rid of this -4 as my denominator. To get rid of something being divided by -4, we're going to do the opposite operation. So to get rid of a -4 as a denominator, we're going to multiply both sides by -4. Now on the left-hand side, the reason I'm multiplying by -4 is because it's going to get rid of it entirely. They're going to cancel out. So all I'm going to be left with is x at the top equals -8 times -4. Since they're both negatives and I'm multiplying, I'm going to get a positive. 8 times 4 is 32. So my final answer is x equals 32. Remember, you always get rid of what's being added or subtracted first, then deal with the denominator or the coefficient. All right, let's look at the second one here. 2/3 x minus 5 equals 7. Okay, again, notice we're trying to get x all by itself. It's being multiplied by 2/3, and then 5 is being subtracted. Let's deal with the subtraction first, just like we dealt with the +7 in the last problem. So in order to get rid of that -5, we're going to add 5 to both sides. Those are going to cancel. So we're left with 2/3 x the positive and the -5 canceled equals 7 plus 5 is 12. Now, 2/3 times x. Whenever you have a fraction in front of x, you can deal with it step by step, or you can deal with it at once. So in order to get rid of 2/3, what I can do is I could multiply both sides by the reciprocal. So I can multiply both sides by 3/2. And that will cancel the left-hand side. Or I can take it step by step. So let me undo all of that. And if I take it step by step, I mean that I'm going to start with that denominator of 3. Denominators are what make things look a little bit more complicated. So I can start by getting rid of the denominator of 3 by multiplying both sides by 3, which will cancel out the denominator on the left and leaves me with 2x equals 12 times 3, which is going to be 36. And now, all I have left to get x alone is the multiplication of 2. Remember, there's an invisible multiplication sign in between the 2 and the x. So to get x by itself, I'm going to divide out the 2. And that leaves me with the 2 canceling out. X equals 36 divided by 2 is 18. And then we're done. X equals 18. So remember, I showed you 2 different ways to get the x by itself when we were at this step right here. You could either multiply by the reciprocal, 3 over 2, on both sides, or you can take it step by step. Multiply out the 3, and then divide out the 2. Okay, let's move on. Number 7, solve the equation below. So we're solving. Okay, now this looks a lot more complicated because we have negatives, we have several variables on both sides, we have parentheses in there. So let's take a look. 2h minus 2 times 4h minus 5 in parentheses equals 10 minus 5h. Okay, so remember what PEMDAS tells you to do. PEMDAS. You start by looking inside of the parentheses and trying to see if you could simplify anything in there. There's nothing we can simplify in there because those are not like terms. So that part we're good on. Let's keep moving. So we've done and looked at the parentheses. E stands for exponents. There's no exponents here, so we're going to keep moving. M and D stand for multiplication and division. Now there is a lot of multiplication here. So let's start with where it's most apparent, and that's in front of the parentheses. So when I'm looking at the parentheses, I want to look at what's in front of the parentheses. In front of the parentheses is not just a 2, it's a negative 2. So as we start simplifying, we're going to multiply negative 2 by everything inside the parentheses. I'm going to bring down the 2h because I'm not going to focus on it right now. I'm only simplifying what's in the parentheses. Negative 2 times 4h gives me a negative 8h. Negative 2 times negative 5 gives me a positive 10. Signs are the same, and when you multiply, it becomes positive. Then I'm going to rewrite what I had on the left, 10 minus 5h. Okay, before we start looking at moving variables from one side to the other, let's simplify what we can. So on the left-hand side, I notice I have a 2h and a negative 8h that can be combined. 2 and negative 8, or 2 minus 8, is going to give me a negative 6h. Bring down the plus 10 equals 10 minus 5h. Okay, let's keep going. So now, I like to always bring over my variables to where there is the larger variable. Now, right now, I have a negative 6h and I have a negative 5h. Technically, negative 5h is larger because it's closer to 0. Both of these are negative numbers. Negative 6 is a little bit more negative, so it is a smaller value. So what I'm going to do is I'm going to bring the negative 6h to the right. In order to do that, I have to add 6h to both sides. That will cancel. So I'm left with 10 equals 10, and then the negative 5h plus 6h gives me a positive 1h, or just h. You don't have to write positive 1h. You just write h. Okay, so now next step, I'm going to bring over the 10 that's on the right side to the left side, so I can get h all by itself. So I'm going to get rid of this 10 so that h can be alone. I'm going to subtract 10 from both sides. On the right side, this will cancel. On the left side, 10 minus 10 will give me 0. Equals. All I have left on the right is h. So 0 is equal to h. You can also rewrite this as h equals 0 as my final answer. Okay, let's move on. Number 8, solve the equation below. So again, we're solving. Now, looking at this equation at first, I notice I have a bunch of parentheses. I have negatives, I have positives, I don't have any exponents, but I have variables on both sides of the equal sign. So just like with the last problem, we're going to go step by step. We start with PEMDAS, parentheses, m plus 5, m minus 2. Nothing can be combined inside the parentheses, so we're going to keep going. Next, no exponents means we're moving on to multiplication and division. Since there are parentheses, I'm going to have to make sure I distribute whatever's in front of the parentheses so that I could free up what's inside. 9 is outside the first set of parentheses. Negative 3 is outside the second set of parentheses. I'm going to have to distribute these out. 9 times m is 9m. 9 times 5, 45. Negative 3 times m is negative 3m. Negative 3 times negative 2 is a positive 6. Since both were negative, turns into a positive when you multiply. Equal sign, I'm going to bring down everything on the right because there's nothing to simplify on the right. 8m plus 31. Okay, so now I'm going to start combining like terms. 9m and negative 3m. 9 minus 3 is 6. 6m. Next I have positive 45 and 6. 45 plus 6 is 51. Change my color. Equals 8m plus 31. Nothing to combine on the right. Now, let's get all the variables to one side. 8m is the larger of the two variables. So I'm going to bring 6m over to where 8m is. To bring 6m, I have to subtract 6m from both sides. This cancels. Give myself a little room. 51 equals 8 minus 6 is 2m. Bring down the positive 31. Now, I'm going to subtract 31 from both sides because I want to get 2m, the variable, by itself. It's always the goal. This cancels. 51 minus 31 leaves me with 20 equals 2m. Last step, I want to get m by itself, so I have to break up this multiplication. So I'm going to divide both sides by the number in front of m. 2 is in front of m, so I divide both sides by 2. This will cancel. 20 divided by 2 is giving me 10. So 10 is equal to m, or m is equal to 10. However you feel more comfortable writing it. Okay, let's move on. Number 9. The perimeter of the triangle shown below is 29 centimeters. Find the value of y. So the perimeter of this triangle, a triangle has 3 sides, is 29 centimeters. So I'm going to write that down. The perimeter, P, is equal to 29 centimeters. They want me to find the value of y. That's our goal. Now let's start thinking about what perimeter means and how that could help me solve for y. Perimeter means all the sides added together. So since it's a triangle, I have 3 sides. 1, 2, 3. This is an equation. Perimeter and the 3 sides added will provide an equation where I can solve for y. So let's start thinking about where I could plug things in. Well, let's start thinking about P. In this case, they provide the perimeter. So the perimeter in this example is 29. Equals. Now let's start thinking about each of the sides. One of the sides is y plus 9. Another side is 2y. And then the last side is 4 minus 1. So I'm going to add all of those together and set it equal to 29. So let's get started. Now I have, for the yellow part, y plus 9 plus the blue side length is 2y plus the green side length is 4y minus 1. All I have to do now is combine like terms. Starting with the y's. I have a y here, positive 2y here, and a positive 4y there. Let's give myself a little room. 29 equals y plus 2 plus 4. So it's 1 plus 2, which is 3, plus 4, which is 7y. Now adding together the whole numbers. Positive 9, negative 1. You're going to get positive 8. Now this is a simple, straightforward equation. We're going to start by subtracting 8 from both sides so we can get y by itself. Minus 8, minus 8. This cancels. 29 minus 8 is 21, which equals 7y. Let's divide both sides by 7, and then y will be by itself. (21) divided by 7 is 3. 3 equals y. Or, like we've said before, y equals 3. So we have solved for y. So let's recap. In this example, they gave us the perimeter, but we still set up our equation the same way. The perimeter equals all 3 sides added together. So we plugged in 29 for the perimeter, and then each of the values for the 3 sides, and solve that equation. Okay, let's move on to the last one on this page. 10. Given the formulas below, solve for the letter P in each. So we're asked to solve for P. Now what that means is we want to get P by itself. So it says P equals, and then whatever it equals. So in each one of these examples, we want to get P by itself. All right, let's look at the first one. P is here. We want to get P by itself, so we want to undo everything that's attached to it. Usually, we start by getting rid of what's being added or subtracted. In this case, there's nothing being added or subtracted. F is being multiplied, and then it's being divided by 3t. I'd like to get rid of the denominator first. I think it's what makes the problem look a lot more complicated. So to get rid of the 3t, since it's being divided by 3t, I'm going to multiply both sides by 3t. On the right-hand side, it's going to cancel, and that's my goal. On the left-hand side, I have 3 times t times d. All of those are being multiplied, but none of them are like terms. So we're just going to put them all next to each other. 3t d, all being multiplied together, is equal to f times p. We're left with the numerator, f times p. Now the last step in trying to get p by itself is to get rid of f. Since f is being multiplied by p, I want to divide out f to get p all by itself. So divide both sides by f. It's going to cancel on the right. And so we're left with 3TD over F equals P. Okay, and that's our goal, to get P by itself. We can rewrite this so that we could switch both sides of the equation, and now P is on the right. I'm sorry, on the left. So we can rewrite it so it looks like P equals 3TD and now it's P equals 3TD over F. So you can have both sides switch. So we can write it the way that we're used to, seeing our variable that we want first. Okay, so notice all we did was rearrange the formula, undoing the multiplication and the division so that we can get our variable by itself. Let's try it again with our second problem here in the middle. Again, we're trying to get P by itself. It's being multiplied by 2 and then divided by G times T. Like I said, I like to get rid of the denominator first. So to get rid of GT, we're going to multiply both sides by GT. So now we have 5M GT. None of those things can multiply together. They're not like terms. There's no number for 5 to multiply by. M, G, and T are all different letters, so all you can do is put them next to each other. On the right-hand side, this cancels. Equals 2P. Last step, I want to get rid of the 2 in front of P. So I need to undo the multiplication. Divide out 2 from both sides. So now we have 5M GT over 2 equals P. One thing I want to note is you can actually just divide 5 and 2 together. So this could be rewritten. If I don't put it in decimal form and just keep it as a fraction, it could be rewritten as 5 over 2 M GT equals P. Because really, when I'm multiplying, or rather when I'm dividing by 2, I'm only dividing the numbers, 5 and 2. So that's one answer. And again, if you wanted to have these switch places so that you could see P first, you can do that, just like we did before. Let's go on to the last one. Now again, for the last one, we're looking to get P by itself. G equals 1/2 times R times P. Now, just like in the last problem that we looked at over here, we could rewrite 5 mgt over 2 as 5 over 2 times mgt. I want to show you the same thing can happen with this problem over here. I could rewrite this problem into G equals 1 RGP, 1 RP all over 2. So these two letters, R and P, can become part of the numerator along with the 1. But we know that we never have to write 1. So it's really RP over 2. I want you to be comfortable with seeing it both ways. Okay, so if G is equal to RP over 2, then what we're going to do first is we're going to get rid of the over 2. So on the left-hand side, when we had this equation, I would do the same thing as what I'm doing here. I would get rid of the 1/2 first. It's a personal choice. I'd like to get rid of whatever that has a denominator. So to get rid of that, we're going to multiply both sides by 2. So I'm going to use the right example first. I would multiply by 2 here, and then multiply by 2 here. These 2's would cancel, and I would have 2G equals RP. On the left-hand side, same thing. If I multiply the right-hand side by 2 and the left-hand side by 2, the 1/2 would cancel out with 2. 1/2 and 2, when you multiply them, 1/2 times 2 is 1. And oftentimes, you don't have to write the 1 in front of the variable. So on the left, I would have 2G equals RP P. Same thing on both sides now. And now the last step is to get P by itself. To get P by itself, I need to get rid of the R in front of it, which is being multiplied to the P. So we're going to divide out the letter in front of P, which is R. Divide it out. 2G over R equals P. Or P equals 2G over R. And this is our final answer. Okay, so we've completed the first page. Look for the next video as we continue in the packet.